In today's lesson, we will cover Introductory Chemical Engineering variables and units, useful equations, and unit conversions. The first units we are going to talk about are mass flow rate and volumetric flow rate. Mass flow rate is mass flowing per unit time, such as grams per second. Volumetric flow rate is volume flowing per unit time, such as liters per second. Next we have density. Density is the ratio of a substance's mass to its volume, such as grams per liter. It is usually denoted by the Greek letter rho. There are special units of density such as degrees API, Bohm, and Twaddle, which are not usually discussed in this course. Specific volume is the inverse of density, so a substance's volume per unit mass, like liters per gram. Specific gravity is the density of a substance divided by a reference density, usually water. Because both the numerator and denominator have density, those units cancel out to make specific gravity unitless. Next we have gram moles. A gram mole, normally known as a mole from chemistry class, is the amount of substance that contains 6.02 times 10 to the 23 molecules. And a pound mole, denoted as Lb subscript m, is the amount of substance that contains 6.02 times 10 to the 23 times 453.59 molecules. This is also measured in moles. Next we have mass fraction. Mass fraction can be found when a substance is part of a mixture. It is the mass of the substance in the mixture divided by the mass of the total mixture, and it is unitless. Next is mole fraction. This is the same as mass fraction, but it is the moles of a substance in a mixture divided by the moles of the total mixture rather than mass. Percent by mass, or weight percent, is mass fraction times 100 to turn it into a percentage. Average molecular weight, or molar mass, is the mass of a mixture divided by the total moles in units of mass per moles, such as grams per mole. One common equation to relate the moles and mass using molar mass is moles N equals mass little m over molar mass big M. Next is concentration. Concentration is a substance's mass or moles per volume, such as moles per liter or grams per liter. When we measure concentration specifically in moles per volume, it is called molarity. This can be denoted with a big M, which is not to be confused with the big M for molar mass. Next is pressure. Pressure is the force exerted per unit area, measured in newtons per meter squared. There are many other units of force, such as ATM, PSI, millimeters mercury, and more. There are many different types of pressure, such as atmospheric or barometric pressure, which is a pressure within Earth's atmosphere. This is usually assumed to be 1 atmosphere unless otherwise given. Absolute pressure is the pressure given relative to a perfect vacuum when P equals 0. Gauge pressure is the difference between absolute and atmospheric pressure. This is an important equation to know. Lastly, temperature. This is the measure of heat in an object, and we use many units such as Fahrenheit, Celsius, Kelvin, and Rankine. Now let's talk about some unit conversions. Let's try converting 10 grams per centimeter cubed to kilograms per meter cubed. When doing unit conversions, we should first write down all of our conversion factors that will be helpful. We are going from grams to kilograms. The conversion between grams and kilograms is 1 kilogram equals 1,000 grams. You could also have written this the other way around, with 1 gram equals X amount of kilograms. Next, we are going from centimeters cubed to meters cubed. First, let's write down the conversion between centimeters and meters. 1 meter equals 100 centimeters, and again, you could also have written this the other way around, with 1 centimeter equals x meters. To convert between centimeters cubed to meters cubed, we will put an exponent of 3 on our units as well as our numbers. So 1 cubed meter cubed, which is just 1 meter cubed, equals 100 cubed centimeters cubed. Now let's make our conversion table. We will set up a table like so. This line here will act as a fraction. The variable and units we are given will be in the very leftmost box, 10 grams, and on the bottom we will have per centimeter cubed. On the rightmost side, we will put in the units that we are trying to get to, kilograms per meter cubed. We don't know how many, so I will just put a question mark. You may need a couple more boxes in between, depending on how complex your conversion is, so feel free to add more boxes if needed. Now I'm going to put these conversion factors into our table. The first conversion we are going to do is from grams to kilograms across the top. The conversion between grams to kilograms is 1 kilogram equals 1,000 grams. I want to get kilograms on the top, and I want to cancel out the grams, so grams must be on the bottom. I'm going to use this line as my equal sign and write this conversion factor with the kilograms going on the top, 1 kilogram, where I'm treating this fraction line as an equal sign, equals 1,000 grams on the bottom. Now you will see why this is useful, because the grams will cancel out. I could have put 1,000 grams on the top equals 1 kilogram on the bottom, but that would not have canceled out my grams. I need them to be on opposite sides so the grams can cancel and I can achieve kilograms like I need. Let's put the conversion between meters cubed and centimeters cubed next. And treating this fraction like an equal sign again, I'm going to put the other side of the conversion, 1 cubed meters cubed. Now once all of the conversion factors are put into your table, we will cancel out any like conversions on the top and bottom. We have grams on both the top and bottom here, so the units will cancel, not the numbers, just the units. We have centimeters cubed on the bottom and centimeters cubed on the top, so they will cancel. The only units that should be left over are kilograms, because we needed kilograms at the end, and meters cubed, because we also needed meters cubed. Now that we have all of the numbers in the table, we multiply across the top, so I'm going to write everything in the top boxes next to one another being multiplied, except this last box. This is what we are trying to achieve, but we will not use it in our multiplication. So we multiplied everything across the top, and we are going to divide it by everything on the bottom, because this line here was acting as a fraction. We have centimeters cubed, so this is 1 centimeter cubed, 1,000 grams, 1 cubed meter cubed. Now we will cancel out any like terms and multiply across the top and the bottom. Grams and grams will cancel, centimeters cubed and centimeters cubed will cancel. The only units we should be left with are kilograms on the top and meters cubed on the bottom, because that was what we needed. When I multiply the numbers across the top, I get 10 times 1 times 100 cubed divided by 1 times 1,000 times 1 cubed. And this gives me 10,000 kilogram per meter cubed. To convert 10 feet per second to miles per hour, we need to write down all the necessary conversion factors, from feet to miles and from seconds to hours. Let's look at the conversion for seconds to hours first. Instead of writing 1 hour is equal to X amount of seconds, we are going to go step by step and convert hours to minutes, then minutes to seconds. 1 hour has 60 minutes, then 1 minute has 60 seconds. Next, let's go from feet to miles. 1 mile is 5,280 feet. Note that you could have just directly gotten the conversion between hours to seconds. However, on an exam, you have to work with whatever conversion factors you're given. So if you were given the conversion between hours to seconds, you could use it. But if you were only given the conversion between hours to minutes and minutes to seconds, you would have to break it up into 2 different conversion factors like we'd have. Now that we have all the necessary conversion factors, we set up the table, and I have 4 columns in this table. You can add more or less if necessary. We start off by putting 10 feet per second in the leftmost column. Remember, this column contains the units that we are trying to convert, and this line acts as a fraction line. Now we will put miles per hour in the rightmost column because this column contains the units we are trying to convert to. In between, we are going to put our unit conversions. Let's start by converting the seconds to hours in the denominator. We need to have something with seconds in the numerator here to cancel out with the seconds in the denominator. We need to take a look at the conversion that contains seconds. This line is going to act as an equal sign, and we are going to put this conversion into our column. 60 seconds is equal to 1 minute. Now the seconds will cancel with the seconds, but we have minutes that needs to be converted to hours. If we look at our conversion for minutes, we need to put the 60 minutes on the top, and this is the equal sign, 1 hour, on the bottom. Now the minutes will also cancel, and we have hours on the bottom. The last conversion is reserved, so we can convert the feet to miles in the numerator. We need the feet part of the conversion to go in the bottom, so it can cancel out with the feet on the top. So we have 5280 feet equals 1 mile. Now the feet will cancel out. The only units we have left on the top are miles, and on the bottom is hours. And this is correct because we needed miles per hour. Now to find the magnitude of our answer, we multiply across the top 1, and we divide along the bottom. Now doing this, I get 6.81 miles per hour. So this is how we do unit conversions, and we can always use this method to convert between any two units. Leave a comment below if you have any questions, and I will leave a link to the related blog post for this video. Thanks for stopping by, and see you next time.